Hi, I'm Craig Rowland, founder of Sandfly Security. Today, I'm going to talk to you about a very unique feature in our product, which we call an agentless password auditor for Linux. Now, on Linux, default credentials with weak passwords are very, very common. We see it a lot. The classic root, admin, or a username with the password is password on it. It's very common on Linux. It allows attackers to get easy access to a system, and at that point, they can begin lateral movement. We even see it on networks that they think they're using SSH keys all over the place, and they find out that there's some systems that still have password activity active on it. It could have been something a user enabled, but for whatever reason, they're there. So the thing here is with agentless password auditing, we actually bring our password auditor straight to the remote endpoint without you needing to do anything else. You don't need to risk bringing password hashes off to an external cracker and risk that they get leaked. We do everything on the remote endpoint. And this is a really efficient way to do it because we can audit a large number of passwords in a few seconds. And actually, this brings up what we call an asymmetric audit feature. And by asymmetric auditing, what I mean essentially is that for an external intruder to try a brute force password list is actually very slow and time consuming. SSH limits the number of passwords that you could try each minute. It might even be a half dozen times before it disconnects you. And then some systems will even ban that IP address if it detects brute force happening. So an external intruder generally tries a very small list of passwords. Sandfly, however, when we get onto a remote system, we could bring over a list of passwords that are 100 or maybe 500 plus more passwords, and we could run through them very, very quickly because we're actually on that remote endpoint. We're not going through SSH. We could look at the hashes and do the direct comparison right then and there. That means essentially, when I say asymmetric, for us, it's very easy and cheap to do a password audit, but for an external intruder, it's actually very time consuming and slow for them to try it on there. That means we could try more passwords than the external intruder can ever hope to guess. And usually that means we can find those bad accounts before the intruders do. Now, the thing here is that with our Sandfly modules, we can look for a variety of problems. For demonstration purposes, I've done a Raspberry Pi Zero. We can run on embedded devices. We can run on appliances. We can run on servers that are 10 years old. We can run on modern cloud systems. We can run on Intel, AMD, ARM MIPS, and IBM Power CPUs, among others. For this device here, I picked a bad password on it. And what I did here, I generated a couple alerts. First alert here is basically the user backup has a password that's the same as their username. You can see it right here. This is a classic example. Backup, admin, root. We see it all the time. We will look for that by default. This type of check takes us literally a split second, even on very low CPU systems, in order to find. We recommend everyone run this type of check. It's very easy for us to do. But we can also do a fuller list of password checks. So we have a few lists built into the product by default. This one here is looking through the top worst small password list. It's about 100 passwords of the top worst ones you could possibly find. This finds heaps of passwords that brute force attackers are likely to use. So again, we're closing that door. So those easy to find brute force passwords are never going to be found by an external intruder if you run this list. Again, it takes usually a few seconds per user for us to run it. We recommend you run this all over the place. We also go look for Linux default accounts, and we also have larger password lists if you want to run them as well. But what's interesting about this is not only can we find user passwords that are here, but all of our modules can actually be cloned. So for instance, this is actually what our Sandfly module looks like here. We have a few interesting things here, which I'm going to explain. First of all, you could put in here the password list. I can make it whatever I want. So if you have those notorious custom passwords that you use all over your corporate network, you could build a custom password list and we could check for those in seconds agentlessly across all your other products. We have a couple other things in here to limit performance impacts in a remote system. Sandfly is very well known for having low performance impacts on remote systems. Our password auditor is no different. We can limit the number of users we can attempt each time. We can look for users randomly each time we go on without needing to exhaustively search for all of them. We do a variety of other things to limit impacts. But basically, by doing the agentless password auditing, we do it on the host. We do it in seconds without you needing to load any additional software on those endpoints. We could find all the default passwords that external attackers are likely to use. And again, we could find those custom passwords that seem to plague virtually every network I've ever been involved with. Those passwords that hang around for years and years and years that everybody shares. We could find those as well. And to make that even better, we work on everything again, everything from embedded systems like this down to your standard servers that are up in the cloud today. So it's available, this password auditor, in our free version and our commercial product as well. So you can use it today in your home network by coming to our site and getting a free license. Or you can reach out to us. We're happy to show you the full product in great detail, including how that password auditor works. So thanks again for watching the video. I'm Craig Rowland, founder of Sandfly Security. I appreciate it. Please check our other videos out for more Linux forensics topics. And thanks again for watching. Goodbye.